This is Pre-Calculus, Chapter 1, Section 6, problem number 83. In this problem, we're trying to figure out how much of this abandoned road we're going to use if we're going to try to pave from this town using part of the abandoned road and building a new road. We want the total cost of all of this to be $6.8 million. So let's look at just a diagram of this with triangles. And what we're saying is that this hypotenuse of this right triangle could either end here, or it could be farther or closer to this town of Grinley, closer here, but or it could be farther away. We don't know, and we're trying to figure out what that is. We're given a few pieces of information. We're given the information that this distance perpendicular to the abandoned road is 10 miles. This amount of abandoned road that we would not be using, we do not know, so we're going to call that X, since we don't know how much of that road we're going to use. And if we use Pythagorean theorem, we can figure that the third side of the right triangle would be the square root of 10 squared plus x squared. The sum of the squares of these legs would equal the square of the hypotenuse. We take the square root to find the length of the hypotenuse. That means there's this pink portion here of the abandoned road that we would be using along with the hypotenuse of this triangle. And so that is the road that we're going to construct. And we need that construction to cost us, as it says in the problem, $6.8 million. So this is the first part of a big word problem like this, or a big application problem, is to really understand what is going on in the question. We don't know the length of the abandoned road, but it's got to be at least 0 miles, meaning we could use none of the abandoned road, or we could use all of it, the maximum length of it. That's to help us to understand that domain of this function, this x, is between 0 and 40 miles, including 0 or 40. But what does it mean when we use none, when our x is 0, meaning we use none of the abandoned road? When we don't take away anything from the abandoned road. If the x was 0, we would use all of the abandoned road, and so we would have all of the abandoned road plus we'd have that 10 miles. What if our x was 40, meaning we didn't use any of the abandoned road? Well, then it would be a straight right triangle, and it would be that entire hypotenuse, which would be the square root of 1,700. And we can figure out what that cost is because it's a brand new road, so it would be $200,000 times the length of that new road, which means if we didn't use any of the abandoned road at all, we would definitely be spending $8.2 million, which is more than what we want to spend. So we know we have to use some of the abandoned road. So let's look at this again. About the amount of the abandoned road that we're going to use is 40 minus x, and that was in that previous diagram. The amount of new road that we're going to use, that hypotenuse, is the square root of 10 squared plus x squared. The cost for the fixing up the abandoned road is $100,000 per mile, and the cost for the new road construction is $200,000 per mile, so we've got that, and it has to equal a grand total of $6.8 million, which I wrote out as the 68 million that we, or 6,800,000, which has there. So we're going to simplify this equation. I'm going to divide everything by 100,000 and get that. Simplify the equation even further by isolating the square root. Once we've isolated the square root, square both sides to eliminate the square root. Now I see I have a quadratic, so I'm going to collect everything over on the left-hand side, and I have that quadratic. I've factored the quadratic, and just thinking of it as a math problem, we've got x equals negative 16/3 or x equals 24. But if you'll recall, the domain had to be between 0 and 40. Well, this is not in the domain, and if we think about what x stands for, you can't have a negative distance. So that is an extraneous solution. The only solution we have here is 24. That means we're not going to use 24 miles of the abandoned road. So if we're not using 24 miles of the abandoned road, then what we are using is 16 miles of the abandoned road. And then to find the new road, we plug that 24 into the equation, into the expression, and we find that the new road is 26 miles. And so that is what we're going to use. We're going to pave 16 miles of the abandoned. We're going to construct 26 miles of new road. And that will cost us exactly $6.8 million.